All right, hi everyone. Due to some technical difficulties, I'm filming this video the old way, the way we were doing it before, and it's like the fourth time I've done it. So I'm going to use the notes that I already had, and I'm going to go rather quickly, and I hope that'll be all right. I just think we'll just get this one posted. So I'm worried about not getting it up, and we'll just finish day 2, and then hopefully by day 3 we'll have the technical stuff figured out. So it's day 2 of series and sequences. We're looking at a geometric sequence this time. And for geometric, like the arithmetic, a sequence is just a list of numbers, but for geometric we multiply from term to term to term. So it's the same idea that there's this pattern that moves us between the terms, but geometric is multiplication, arithmetic, remember, was addition. So when you see like 5 to 10, 10 to 20, 20 to 40, we are multiplying by 2 every time to move between these terms. So that's called the fixed ratio. The fixed ratio is the amount that you multiply by to go term to term. In the arithmetic, it was called a common difference. So it is possible that the Regents would just list these numbers and say what is the fixed ratio. You need to know that that's the vocab word that means that, but really all you're doing is investigating to see what happened term to term. Here's example 2. Suppose you've got 30, 90 to 70. We're multiplying by 3 every time, but since we're going positive, negative, we're multiplying by a -3 here. That's our fixed ratio. And you may be able to figure that out quite simply, or if you can't really figure it out and you are unsure, all you have to do is divide. So if I had done 40 divided by 20, I'd get 2. Or 20 divided by 10, I'd get 2, or 10 divided by 5. So you pick any number and divide by the one right previous to the left, and that would give you your fixed ratio. So -90 divided by 30, the answer would have been that. All right, so like the formulas the other day, there is a rule, an a sub n, and our a sub n rule for the geometric is a1 times r raised up to the n minus 1. There's our formula. I was looking for a nice pencil. And again, where a1 is just the first term, r is the fixed ratio, and n is, the number of terms. So let's do an example here. Suppose I've got 2, 6, 18, ... And it says find a sub n and the 7th term. So remember, find a sub n just means find the rule that made this pattern. Typically you would look and investigate to figure out arithmetic or geometric. We know that it's geometric because that's what we're doing today, but we're multiplying by 3 every time, right? To go from 2 to 6, 6 to 18. So that means my fixed ratio is 3. And as soon as I see an, I'm just going to reach for that formula. Again, you do have to memorize this one because it's not on the reference sheet. So it'll be a sub n equals 2 times 3 to the n minus 1. And that's just it. A1 is 2, the first term. The fixed ratio is 3, and that is finished. Do not multiply 2 times 3 and write 6 to the n minus 1. Only the 3 is the n minus 1, not the 2, so it just sits like that and it's done. And then when they ask you to find the 7th term, we're going to go a sub 7 equals 2 times 3 to the 7 minus 1. This answer here is actually 1458. So at this point, you can reach right for the calculator and type it straight in. You can type 2 times 3 to the 7 minus 1 or 2 times 3 to the 6th. But again, don't write 6 to the 6 because that would not be correct. You just want to basically find the value of this. Real simple, straightforward, just a nice kind of, basic a sub n formula, plug in, get the rule, and then use the rule to find something else. All right, next up, let's do one more example here. Example 2. I've got 0.5, 3.5, 24.5, and 171.5. Whoops, that's a 0.5, ... If it says write the rule, and then find a sub 8, Your first question would be, what is my fixed ratio? What am I multiplying by to go term to term? Maybe even your first question is, I don't know if it's multiplication or if it's arithmetic or geometric. So what you're going to do is 3.5 divided by 0.5. Oh, that's 7. Let's do one more. 24.5 divided by 3.5. That is also 7. One more if you want to just show that it works every time. Also 7. So I'm just picking a number, dividing by the one right next to it. That tells me what I multiplied by. So I multiplied by 7 every time, term to term. That's my fixed ratio. The rule is another way for them to ask for a sub n. So the formula is a sub n, a1 times r to the n minus 1. So my rule is going to be 0.5 times 7 to the n minus 1. And that's just it, finished. For a sub 8 now, to evaluate that, you would do 0.5 times 7 to the 8 minus 1. And again, I would not try to do the PEMDAS or figure this out by hand. Honestly, I would probably just type that in. You can use the times key or, oh shoot, I'm sorry about that. I put an 8 there, we want a 7. There it is. So I just did 0.5 times 7 to the 8 minus 1, and that is the correct answer. 411, 771.5 actually, I believe. And that's done. Okay, there's one other formula. This one is on your reference sheet, and that is for the sum of a geometric sequence, just like the other day. Here's your sum formula. Find the sum of a geometric sequence. That's a1 times 1 minus r to the n over 1 minus r. I gave you a minute to write it down, but again, this one does not have to be memorized. It's here on the reference sheet, again, right above the normal distribution curve. So this is the one, the arithmetic one we did the other day. This is the one we're doing today, the geometric one. And you'll notice that there's no a sub n in this formula. So unlike what we did on day one, I'm never going to have to use the first formula and figure something out to plug in. This is actually a little bit easier. The only thing that it involves is the first term, the fixed ratio, and then the number of terms that we're trying to find the sum for. So here's our first example. Find the sum of the first 8 terms of -5, 15, -45, 135, etc. So again, if you investigate what is happening term to term, my fixed ratio is -3. That's what I'm multiplying by. As soon as I see sum, I grab the sum formula right off the reference sheet. And I'm just going to put the -5 in for A1. I'm going to put -3 in for R and 8 in for N because they wanted the sum of the first 8 terms. So the formula is pretty easy to work with, but maybe a little bit tricky to get this into the calculator. I would type this exactly as it appears there. So I'm going to open up a fraction and do -5, parenthesis, 1 minus, parenthesis, -3 to the 8 over 1 minus -3. That is the correct answer of 8,200. So don't try to think, wait, shouldn't this make a positive here? Because it's a negative number to the power of 8 before that happens. It all has to do with the order of operations. So usually when students try to distribute or do things piecemeal, it comes out incorrect. I would encourage you to just one step on the calc together. I had one more, and this will be our last example, and we'll be done. Find the sum of the first 5 terms of 3, 9, 27, 81. This 243, again, I kind of have notes on here because I've already filmed this several times, but the 243 wasn't given to us. And I just wanted to remind you that if you're really desperate and you have no idea, you realize that you're multiplying by 3, just do 81 times 3, which makes 243, and then I've got 1, 2, 3, 4, 5, I've got 5 terms, I could just add them up. And that's so much simpler and quicker than using the formula. However, most likely the Regents will be saying only an algebraic solution will receive full credit. So what you're going to do again is use that S sub n formula, where the a sub 1 is 3. Our fixed ratio was 3 because we're multiplying by 3 every time, so there's 2 different 3's. And then since we want the sum of the first 5 terms, we put a 5 in for n. So it's just A1, the fixed ratio, and the number of terms, and then this goes right in the calculator and makes 363. Pretty straightforward as long as you know what everything stands for. What I've done here with this little arrow is remind you of one other thing, and we can, investigate this a little further in class, but I wanted to show you this summation series. Remember that we used this big sigma in our previous unit, and the big sigma was the sum of the terms, right? And this thing that they just asked us about was the sum. So we had done a couple examples where you had to work backwards. This would be 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. The rule is 3 to some power, starting with the first power, and if I want the sum of 5 terms, I'd be going up to the 5th. So this, if I did it out by hand, would be 3 to the first, plus 3 to the second, plus 3 to the third. And that's where those numbers came from. 3 plus 9 plus 27 plus 81 plus the 243. That will also make 363. Or if you just use the big summation button in the calculator, if you could recognize the pattern and come up with this, you could have typed that in and it would also give you 363. So I sort of wanted to tie those together for you. Either of these would be acceptable, but truly when it says sum and it's a geometric or arithmetic, since this formula is on the reference sheet, I usually do it this way. I've got the formula, they give it to me, and it's not hard to me to plug in, where this I have to think a little bit about what goes where. All right, so thanks so much. I hope that wasn't too quick, but it's very similar to what we had last time, just 2 formulas, an AN and an SN. Sum, you are given the AN you have to memorize, and it's all about geometric this time. So thank you, and we'll see you tomorrow in class. Bye, everybody.